Abnormal sounds within the axle are either bearing or gear noises or combinations of both. Bearing noise is a continuous growling or grating sound which may increase or decrease with changes in load and speed. In comparison, drive pinion and gear noise is distinguished by its periodic nature. This is more of a tone than a grinding sound which may be heard only within a certain speed range on either drive or coast. If the diagnosis narrows down to gear noise, incorrect adjustment can be the cause, and a gear tooth contact pattern test is the best way to check it out. To run a tooth contact pattern, drain the axle, remove the cover, and wash the gear teeth clean to prepare for the test. Also, disconnect the propeller shaft so you can use a wrench to turn the pinion and drive gear under a test load. Brush the drive gear teeth evenly with a light coat of yellow iron oxide or titanium white paste. If the coating is too thick, the pattern will smear. To get a distinctive pattern, we put a friction load on the drive gear by prying against the rim of the differential case or by partially applying the parking brake with the drums in place. With load applied, turn the pinion to rotate the drive gear one full turn in each direction. If you rotate the gear more than this, any pattern variations will average out and cover up indications of excessive gear or pinion runout. Now, if the pinion depth and backlash settings are correct, the most distinctive part of the contact pattern should be near center on both the drive and coast sides of the teeth. When the gear and pinion are under actual working load, the tooth contact area spreads out, especially toward the heel ends of the teeth, which explains why a good contact pattern should be near center under a test load. If the most distinct part of the pattern runs off the teeth or is near the top or root, it indicates a tooth overload and interference condition, which produces noise and can result in chipping or other tooth damage. The tooth contact pattern is not acceptable if it is way off center on both sides of the gear teeth, usually as a result of incorrect pinion depth setting, or if the pattern changes location around the gear because of excessive runout. Where the tooth contact is high on the heel end of the drive side and also high on the toe end of the coast side, a thicker shim is needed to move the pinion in toward the center of the drive gear. This moves the tooth pattern toward center and downward. In comparison, where tooth contact is low on the toe end of the drive side and low on the heel end of the coast side, the pinion must move out away from the drive gear center, so a thinner shim is needed. This moves the tooth pattern toward center and upward. Gear backlash, which is far out of adjustment, also contributes to a heel and toe pattern. However, since the effect of backlash on the pattern is small, changing this adjustment will not correct a condition where re-shimming is necessary. When the heavy part of the pattern moves back and forth on the teeth around the gear, it usually indicates an excessive amount of runout. If the pattern repeats itself approximately 3 times around the gear, the pinion is the probable cause. If the pattern movement repeats itself twice on opposite sides of the gear, the problem may be in the drive gear or the differential case. Repositioning may help to reduce gear runout, but excessive case runout calls for a new part.